Here we go. And there'll be a slide deck. This slide deck is already posted on our assignment, which I haven't posted yet, but when I do, you'll be able to get to it. So classes. A class is a blueprint or a recipe for a real world object. So these objects have attributes, which are variables, and behavior, which is controlled by methods. I'm going to give you examples of all this in just a second. You create objects using the new keyword. For example, right here, here's one we've done a bunch of: scanner, scan equals new scanner, system.in. That is actually creating a scanner object. You may or may not have realized that that was what we were doing, but and it doesn't have to be named scan. It could be called your mom or anything. I find that lots of times when people name it something other than scan, then they get confused later. So I've taken to just calling it scan. Back to classes. A class is a recipe or a blueprint for a particular type of object. Think about literally an apple pie recipe. You can have the recipe on paper or on your computer, and then you can use that recipe to make as many apple pies as you have dough and apples and other ingredients for. Just remembered to get some more dough for my Thanksgiving pie. So the recipe is the class and the pies are the object. And I'm going to show you guys a short video here. Very short, 1 minute and 39 seconds.
Okay, in computer science, we want to model things that exist in the real world. And we're going to use code here. We're going to use Java code to model those things. So we're going to have something called a class, which is like a blueprint for an object. So if this dog is my object, it's just a little stuffed dog. You can imagine that I've got a blueprint that's the instructions for how to make a dog. Okay, that blueprint is called a class. So with that class, that's my blueprint. I can make dogs. Those dogs are my objects. I can make a bunch of them, and they all follow the instructions of that class, which is my blueprint. But then I can have actually different ones. So these are different instances of the class dog, or whatever this stuffed dog is that I'm making. So these are objects of that class. And then you can imagine each object can have different attributes. So these are different properties about it. We'll use the key term attribute, and then we'll also use instance variables. So you can see these ones are different colors. And so you can think about those different colors are the different attributes or the different instance variables. So they still use the same blueprint because it's like still the same dog. So they still use the same class, but there were details about them. Those were the instance variables or the attributes. Those were the things that were different between each object of the class or each instance. And we'll use instance and object interchangeably. So this is one object. And then the things about these objects, those are the attributes or their instance variables.
Make it stop. I thought she was clear and to the point. All right, so next slide. A class is declared like this. It's been happening all year long. All of our programs in REPL start with class main, but we're going to be talking about custom classes today. So they will start with class and then the name of the class, or public class and then the name of the class. If you use public in front, then the file name that the class is in has to have that exact name. I mean, it has to. If you said public class rectangle, then there's going to be a text file, a Java file that says rectangle.java. This isn't really going to be a problem for us in REPL because it's just taking care of it all for us. But so far. And if we were writing standalone Java code on our computers, we have to be more careful about what we're naming our files. But that's not going to be a problem for you in this class. Class names should start with a capital letter. So notice it's capital R for rectangle. And then the body of the code, the recipe or the blueprint, is all inside of a set of curly brackets. So inside a class, up at the top, we define the variables, and variables must always be declared private. So we're going to discuss this more next time. So here's a simple class, public rectangle. Oh, it's missing the word class. Sorry. I'm like, what is wrong with this picture? Right here. I'm fixing it right now because it bothered me. So here's a class, public class rectangle, and it says private int width, private int height. That is, those are variables that are attributes or instance variables of the class rectangle. You can just call them variables. And they give objects their differences, like those dogs. There was the polka dotted dog and the solid color dog. Next, a class typically has one or more constructors, and these are a special type of method that fills out the variables with appropriate information. So when you create, they're called when you create a new object. When you make a new rectangle, this rectangle code is expecting that you're going to send it two integers, one for the width and one for the height, and then it goes ahead and sets those internal variables to these numbers that you send over. So here's private int width, private int height, and then over here, when you say new rectangle, you have to send it a width and a height number, and it goes ahead and stores that information in the new object. Constructors are always public. They don't have a return type. So notice it doesn't say public int or public void or public string. It just says public rectangle. That's how you can tell something is a constructor. It has the word public and it has the name of the class right after it. Has to be exactly that. The word public and then the name of the class with the exact name capitalization. Any questions? Okay, and then classes have methods or can have methods, they don't have to. And we say that these methods define the class's behavior. Because if you just had variables, you create this object that's sitting there, it's got these variables. Okay, what are we going to do with that? But the methods let you do things with this object. And we'll have plenty of examples here today. But this method returns the area of a rectangle. So if you call get area, this rectangle class will throw you back the width times the height, which is how you find the area. So methods can be marked public or private, but let's just make them all public in our class. We'll talk about this another day, but there's really no need to ever do anything but for us to have public methods. Methods have a return type. I mentioned this earlier. So here's two methods, one that has a return type of int and one that has a void return type. In other words, when it's void, it actually doesn't have a return of anything. So if you have public and then you have some value here, some type of variable, so whether it's an int, a string, a double, or a Boolean, that's that method's return type. And so you have to have a return statement inside the method, and it has to return a value of that type. The code won't even run if you don't set that up. And then, but you can also have methods that are void, which means they don't return anything. And so then you'll see this method doesn't say return. I mean, it can do all kinds of things. It can set the variables, it can print things, it can calculate things, but it doesn't have a return call in it because you said, hey, this one's not going to return anything. And so this will come up, like if you try to print the result of a method that doesn't return anything, Java will say you can't do that because there's nothing to print. And then, I mean, that's just one place where it would show up. I wanted to call out specifically a method that's called tostring. We're going to be writing these, I think, pretty much all the time now for our custom classes. And a tostring method returns a custom personalized representation of the class. So if you don't have a tostring method and you print an object, you'll get something like this over here on the left. I took out, our frog class has a tostring, but I took it out and printed, and it says frog at, and then this is actually a memory address. It's like, it's useless to us as humans, but it says, hey, this is a frog object and this is where it is in memory. So not very useful, but down here, this is specifically the tostring method that I wrote for the frog class. We did the frog stuff a couple units ago, a lot of frog stuff, and this was how we printed the frogs. And let's look, I didn't ever explain it to you because we didn't know how to do for loops, but what this does is it creates an empty string, and then it repeats from I is 0 all the way up to just under the location, and it adds a period for each spot that the frog has hopped, and then it slaps the little at symbol at the end and returns that as a string. And the other code that was trying to print the frog gets this string and then prints it. So then that way we would get this dotted line with the at symbol instead of frog at 6FF3C5B5. So you'll see shortly. So today, in just a minute, we're going to write a custom class from the ground up together for a person. But first, I want to just show you some of the custom classes that we've used so far. So this is going to be today's assignment. But if you look over, I know it's small on your screen, but over here on the left, we have main.java, which is where you're going to write your code, most of your code. But then I've got here also listed book.java, circle, frog, and rectangle. These are things we've done before when I was introducing different things in units 1 through 4. So book has a title, author, and year, variables. It's got 3 different constructors. So you can create a book that has all 3, title, author, year. You can create a book if you just know the title. And we even made it so you can create a book if you don't know the name of it or when it was written or who wrote it. And then here's a tostring for the book class. You can look at that at your leisure. Here's the circle class. It has just one variable, the radius, and it has get area, get perimeter. Notice it doesn't have a tostring. So if you tried to print this, it would, if you just said print a circle object, it would print funky. There's frog, which we've done a lot of frog hopping here. Frog just has one internal variable, the location. When you create a frog, the location set to 0. This is the constructor right here, where when you create a frog, it sets the location as 0. Then you can hop 1 space forward or n spaces forward. You can get the location of the frog using the get location method. And then here's that tostring I showed you. And then rectangle has 2 integer variables, width and height. And here's the constructor, and here's a couple of methods, 4 methods. Now, so we've used these things already before. My thinking was that I wanted you to work with each of them. So in a second, we're going to be done with the notes, and I want you to come and open up this assignment. I'll post it. And then I want you to walk through and do all these things. And in the end, I'm asking you the last thing after we've done these, poking around with the book, the book, circle, frog, and rectangle classes. I want you to actually write the person class. So I have the person class here, and it's empty. So you'll be, you're going to write the whole person class, and then and write some tests for it. And then I have a separate, another assignment where I'm going to have you write a storm class to represent hurricanes, which I thought was appropriate given how there's still a hurricane in the Caribbean or down in South of America anyway, destroying things as we speak. Category 5 hurricane called Iota. Any questions before we start working on this? I'm going to stop